Welcome to projectbazaar.com. Now let me discuss about the title of the project. Our title is TRACON, that is Interference Aware Scheduling for Data Intensive Applications in Virtualized Environment. The main objective of this paper is maintaining a low system overhead, and also it leads to the significant improvement in both application performance and resource relations. In this, we are going to develop a TRACON for virtualized data centers to mitigate the interference effects from co-located applications. So, to achieve this goal, we incorporate the proposed non-linear interface technique. So, it leads to significant performance in application performance and resource utilizations. Now, let me discuss about the abstract of our process. Large-scale data centers leverage virtualization technology to achieve excellent resource utilization, scalability, and high availability. Ideally, the performance of an application running inside a virtual machine shall be independent of co-located applications and VMs that share the physical machine. However, adverse interference effects exist and are especially severe for data-intensive applications in such virtualized environments. In this work, we present TRACON, a novel task and resource allocation control framework that mitigates the interference effects from concurrent data-intensive applications and greatly improves the overall system performance. TRACON utilizes modeling and control techniques from statistical machine learning and consists of three major components. They are interference prediction model that interfers application performance from resource consumption observed from different VMs. Then the interference aware scheduler that is designed to utilize the model for effective resource management, and the task and resource monitor that collects application characteristics at the runtime for model adoption. We implement and validate TRACON with a variety of cloud applications. The evaluation results show that TRACON can achieve up to 25% improvement on application through a virtualized environment. Now let me discuss about the data flow diagram of our process. In our process, first our process starts with number of tasks. In the sense there are various number of tasks like sending messages between network like TCP, like FTP. That type of task has been taken. In that we have 100 tasks. That 100 tasks are placed in a queue. So tasks are waiting for receiving their for allocating the task request to the VMs. So next is after the task has been allocated in queue, in that resource prediction model we are going to collect and validate the status of resource utilizations of VMs. That means we are going to get the resource utilizations of VM1 and VM2, and also get the load of VM1 and VM2. After I get the resource prediction, predict the resources from the VM, we are going to in the interference aware scheduler model. In this, we are going to cluster the tasks based upon the loads. So based upon the loads, in the sense based upon the size of the data, we are going to cluster the process by using the k-means plus clustering algorithm. After we clustering the algorithm, and then we are going to monitor the process. Then in the process we are going to monitor the process. In that we are going to monitor the process based on the interference aware scheduler and resource prediction model. So in that we are going to monitor means get the machine status and scheduling tasks from the scheduler, and we have to schedule the jobs based on the VM load. So if there is a VM1 has low load, then a VM2 we are going to allocate the tasks to VM1. Now let me discuss about the demo of our process. First, our process starts with home.java. Here, just right click and like home.java. Here we have four packages like interference prediction, monitor, task scheduler, and interference aware scheduling package. Uh, so get the tasks and number of tasks in queue and send tasks to the task scheduler. Just a task scheduler at the Java in task scheduler package. Just click the tasks in queue. A task has been received from the interference aware scheduling package. Then after we are going to cluster the jobs, schedule the jobs based on the machine learning technique called k-means plus clustering. Here we have a number of tasks and show. Then get cluster values like high, low, medium. Then predict the task loads. Here we are going to predict task loads. And here we are predicting a low loaded and medium loaded and high loaded jobs, and then get number of tasks based on the low loaded, heavy loaded and the medium loaded, and get throughput estimation based on the number of tasks and the time taken, and cluster A throughput and cluster B throughput and cluster 3 C throughput, and send these loaded jobs to application server. Just run the application server in monitor framework. Just right click and run file application server .java. Just click from TS task scheduler, and in the task scheduler we have to send the tasks to loaded tasks to resource monitors. Then we are going to monitoring the resource of VMs. Just right click and run the files VM1 and VM2. In VM1 already it have 50 jobs, and we have to predict load predictions, and then send this loads to application server and get and predict the load of VM2 and get a load, and then send it to the application server. Just click the application server, just click the VM1, send to the application server. VM1's load has been placed in a resource and monitor. Then just click the from VM and send it to the application server. It has been received here. And then analyze the load. Here VM2 has a high load, task allocated to VM1. Okay, task allocated to VM1. Go to the VM1. Receive the process. Tasks received. So this is the process. Then we are going to evaluate the performance based on the throughput. Here we are evaluating performance based on UOPS improvement, cluster A, cluster B, cluster D. This is a complete demo of our project. Thank you for watching.